Fire Escape Engineers Inspector Summary Video. We're here in White Plains. The fire escape here is one of 7. This one is going to be very typical of all the fire escapes. I'll go in great detail on this specific fire escape, what needs to be done. And the first one that we have, that's going to be a model that you're not going to see down below, is this railing. See this railing right here? This railing keeps me. I have approximately 12 inches. Look at my foot. My foot is about 11. I have only 12 inches to come out of this window. A lot of the windows, the sills are cracked, feeding water to the fire escape supports down below. So this rail is what keeps me from falling into this pit. None of the fire escapes below have this railing as a protective. So we need all the fire escapes below need a railing protective. This fire escape is showing age of at least 25 years of non-painting. I'd say almost 50 years, but at least 25 years this fire escape has not seen a paint job. So this fire escape is older than 1978, so it's presumed to have lead, so EPA rules apply. Must be a licensed renovator due to the lead content on this fire escape. Number 2, we've got square head bolts, which is original hardware. We got rivets and squares, original hardware. So when it's original hardware, what it means is that this fire escape, throughout the entire fire escape, 7 stories on this one, doesn't have one new bolt. And it's very impossible for a fire escape of this age not to have some changing out of bolts, and I'll explain why. In this corner is an example. That used to be a bolt, it's gone. That used to be a bolt, it's gone. So this railing is unsupported. Freeze and thaw is getting in here. Water gets in here, and through ice jacking and rust jacking, it pops this out. So this is one of the small holes, but this is not properly packed into the building, and it's causing problems in the structure. So now as I'm going this way, you can see this rail is keeping me from falling into the pit. Down below, you don't have such a protective. Through freeze and thaw, this is what happens. The water gets in there, and not only does it affect my iron, and the iron causes rust that causes this. And the water gets in there, causing ice jacking that causes this. And this is what you can do. You can basically start pulling the cement out. So it's here, and you keep it going, it'll just let you pull the other one came out easier, but look what's happening in there. It's a combination of rust jacking and ice jacking. Then you get to every corner. Every single corner, I'm going to show you what's left of a bolt. Rust is underneath, jacking it up. What's left, there's nothing. There's no bolt, there's no bolt. Original hardware. Going down the stairs, I have a railing on the left side, which is very small. Should I fall, there's a possibility of me falling to the left. On the right, there's no railing at all. So if I was to fall, I would fall straight down into that cavity, and then I would fall back into additional stairs because there's no protective rail similar to this one. So it's very important that you see this rail, and there is no rail down below keeping me from falling into the pit. Staircase, 100% of the staircases are full of rust, and the rivets it's all riveted. Original hardware, square heads, rust inside. Original hardware, square bolts, rust inside. Rust is inside every one of these treads, and that's starting to push these clips apart. So we'll show you as we go down that ice jacking and rust jacking happening right there again. This is a stair stabilizer. As you can see, all that. Now, not any evidence of maintenance. Heavily corroded, a lot of paling paint. So we're gonna have to be very careful as to what degree we go to get all this paint and capture. Look at the sills. The sills are all cracked. This sill is feeding water into my support. My support is all blown out, and so this support now needs to be repacked. You got a severe fracture here, which needs a mason to do this, not me. And look at that line. Now there's a major stress fracture there, so most likely this is going to have a mason come in here and work on this, because right now this sill is all cracked and feeding water in there. Look at all that water getting in there, feeding this mini support. Okay, let's continue. Every tread has rust in the connection, so all these need to be rebolted, and they're riveted. And that means you're gonna have to cut the rivet head on the outside. You have to cut that rivet head, and knock it out with a cutter. Pop these rivets out, take the treads out, clean them, prime them, put them back. Okay, while we're here, let's look in that corner. The angle was on the ground of this floor, so it's an unsupported corner now. Okay, look at all the cracking. This whole top floor, look at that crack that's coming from that sill. You follow that crack, and it goes all the way through every support. It's not evident down below. This is probably the worst floor that I've seen so far. But that crack is 12 feet long. And that water getting in, look at what it's doing here. This is a masonry crack. It's going up this way, diagonally, through this beautiful sill, up that way. So this is all water coming in from the fire escape, from that sill that's all broken. So this needs to have other things done here in order to get this dealt with. Okay, back to the fire escape. Photographs will show every corner is blown out. There's not one corner that has the head still left on the nut. The tiebacks, they're spalled out. They're not tied back correctly anymore. See the rail that's missing here? This rail that's missing here, if I come in, I have to hug the wall. Otherwise, if I was to make a miscalculation, I would fall into the pit. So, no rails. All of them need rails on the inside so that people, as they come around, they don't have time to think during a fire. And then going down again, missing rail on the right. We need to extend the rail on the left a little higher so that in case something happens, my hands can grab it on the left side, but on the right side definitely need a rail. Again, missing bolts, unsupported corners, original hardware. And you let spalling happen long enough, this is what occurs. Huge gaping hole. Huge. Water's getting in there every day, and that water is causing other damage to the physical wall. Never mind the fire escape, the physical wall is getting damaged. And no bolts in the back. So the only thing holding this corner is really what's left of the integrity of this corner. Because the bottom, and here there's nothing tying. So this rail. So you got some life safety issues happening on this building. Going down. Again, the E-clips, which we call them the stringer clips, all need to be changed out. Severe rust on every tread. Oh, by the way, this is the clip that came from that corner up there. All right, that corner up there, this is the clip. So as you can see, and that's what happens to your rivets. There's nothing left of them. Because this fire escape has had severe rust. Severe. Okay, coming back down. It's going to start repeating itself. Rust on every connection. Rust on every connection. So these need to be hammer tested to make sure that none of these are false. That'll be during a phase 2 inspection. Again, every bolt is gone. Corner. So a lot of rust jacking happening. Missing rails. Missing rails. Severe rust. A lot of flaky paint. I have to be very careful when I cross over. There's another shot of just water now starting to spall. There's rebar there. See, that rebar gets water and then it just spalls these sills. Just general maintenance. And that spalling sill has caused that to crack right there. So a lot of water's coming from these windowsills, coming down and destroying. Ice jacking is occurring. You can see rust jacking right there. Look at the rust underneath, just bulging the rail. Bulging the rail. All the heads are missing though. So now it's starting to repeat itself. Stringers, railings missing, inside rails missing. Every tread has rust. Every sill has problems and feeding water, causing masonry. All this masonry belongs to a mason, not to a ironwork company. So they can repack temporarily the situation, only to have a mason come in here and open up some of these lines here and redo the brick. But the fire escape can be repaired prior to the mason getting in here. The mason company, if they're doing any work on this fire escape, they must release the fire escape and the sign-off, because after the repairs are done, they need to be re-inspected and certified, because while they're working, they're probably gonna have to get on the fire escape. They have to release the ownership of the building and release the any company that did work on here, temporarily suspend the certificate, because they're going to be using it as a work platform, and they're responsible for anything that could happen on the fire escape, because the fire escape was not made to be used as a work platform. And if they're going to use it that way, they have to take all the liability associated with that. There's all that rust. Huge, huge. All right, so now it's just repeating itself. There's a clip right up there where you can see, perfect shot right there. It's no longer attached. Okay, it's things like that. Stability of this fire escape is suspect. A lot of bricks popping. Okay. Cement spalling. This is a start, then the holes just keeps getting bigger and bigger and bigger until it just blows out all these bricks. There's a piece of it where the brick is actually gone. Doesn't tie back into the building anymore. Rust jacking. So a lot of these rails are no longer supported by anything. No bolts, no heads. You know, this little rail going along. No heads. You know, there's no heads holding these rails. Again, no protective to keep me from dropping into the pit. Severe bulging. You can see the bow of the top of the rail. This is the staircase. This is the ladder system. It goes down, and that ladder system drops down to the ground. This is the top. You can see it needs to be tied. The only thing holding that hook down below that grabs the ladder is just one old square bolt. We need to talk about that. So now let's go down, see if we have anything. We have some metal sills that are starting to get water from above, and these things are happening. So this is a lot of severe scraping. Scraping first of this fire escape, then work can commence, because you got a lot of scrapings. I would scrape this fire escape down so then that the work can commence. So because the EPA requirements get all the scrapings down first. 100% of this fire escape should be scraped. Can't sandblast. EPA doesn't allow. Allows to encapsulate the whole building, and the cost associated with that is higher. 100% of the treads, rust. So the sills are so bad. There's another sill feeding water. This lower floor has got problems with every single support. This one's actually splitting a double support. Very bad. Look at all this. Okay. Rust jacking, tons of rust jacking. The landscaping on this building has changed. This ladder's supposed to drop another 2 feet. It didn't. Look at all that rust. Look at all that holes. So I can put my finger inside there. Okay. So all original hardware. No evidence of any maintenance ever on this building. And I suspect all the other fire escapes are going to be the same. So, in summary, let me just look at this hook here first. That hook is only being held by that piece right there. It needs to be changed out. This is holding the ladder. Okay. With that being said, the summary. 100% of this fire escape needs to be scraped. 100% of this fire escape needs to be rebolted because everything is rust jacked. Everything is popped, all its bolts. Life safety issues on all the rails. So it needs some emergency repairs in order to make it functional until such time that permanent repairs come take effect. Which means coming in here and popping some of these bolts. Not necessarily have to clean out any of the rust for now, but get new bolts in here to guarantee that the structure is going to stay. So whatever vendor, it's definitely going to need engineer oversight. So the vendor needs to coordinate with us to give us his game plan and how he plans to repair the fire escape and secure the fire escape until such time that permanent repairs take effect. The city will require a permit, and you must be a licensed renovator to touch this project. Everybody must speak with the inspector of record, which is Ivan Fernandez, and otherwise no work can be performed unless he has, and we will provide him inspection criteria as well as repair criteria and guidelines for the engineer oversight required to get this fire escape certified in lieu of a load test. Any questions? Fire escape engineers, Inspector Meneses here. 800-649-3333. 800-649-3333. We're here in White Plains, New York.